Okay. So I am gonna go over the review. Don't forget the test is on Monday, and it is 24 questions, 8 questions from each topic. You need to bring your review to class Monday, completely filled out, all questions answered for a free 100. Let me think. Today, you need to make sure you do your attendance quiz by 3 p.m. I think that's it. All right, so we're going to go ahead and get started. This video might be a little bit longer. We'll just have to see. All right, so the first question says, consider the geometric series 2, 6, 18, and 54. Find the common ratio, R, and the sum of the first 12 terms of this series. So, from 2 to 6, we are multiplying 3. And we know we're multiplying because it's geometric. From 6 to 18, I multiply by 3. And 18 to 54, I multiply by 3. Okay? So, my common ratio, R, has got to be 3. Okay? Now, it says find the sum of the first 12 terms. So that is why we have those plus signs between each term, because we are finding the sum. So, yesterday we wrote SN equals T1 times 1 minus RN over 1 minus R. All right, so number of terms is N. So I'm looking for S of 12. T1 is the first term. Which is 2. We said N is the number of terms. So it's looking to find the first 12. R is our common ratio, and we know that is 3. So you're taking this information and you're plugging it in to this equation right here. Now, I'm going to erase this so I have some room. So we're saying S of 12 equals 2 times 1 minus 3 raised to the 12th power over 1 minus 3. All right? So, now what you can do is I am going to go to our calculator. All right, and first we type in 2 parentheses, and to get a fraction bar, we hit alpha y equals, enter. On top is 1 minus 3. Raise that to the power of 12. To get to the bottom of the fraction, we use our down arrow and we say 1 minus 3. Now, I don't want to close my parentheses on the bottom, but I want to close it for the entire fraction. Now, what's on your calculator should match what we just wrote. If it does, you hit enter, and you should get 531,440. So that is the sum of the first 12 terms of that geometric sequence. Okay? All right. Number 2. A ball is dropped from an initial height of 15 feet. Remember, initial height tells us the first term. The ball bounces and rebounds to a height of 25% of its previous height. It does this many times. What is the function rule used to model the nth term of the sequence? So anytime you see nth term and previous height, you know that you are going to have to use that recursive definition. Remember, recursive definition means you have to know the term before to get the term you're looking for. So I would have to know term 2 in order to get term 3. Okay? So in the first box will be our first term. Then we have multiplication sign, because we know it is a geometric sequence. And the next box will be our common ratio. And then the exponent will be our recursive definition. Okay? So, first term is 15. Now, our common ratio is 25%. But we can't type a percent into our calculator. So we have to change 25% to a decimal. So we get 0.25. And then our recursive definition is n minus 1. So I'm actually going to write this at the bottom where you have more room and you can see it better. F of n equals the first term, which is 15, times the common ratio, which is 0.25. And then to know the nth term of the previous heights, we have to use the recursive definition of n minus 1. Okay? All right. Number 3, it says consider the sequence. -1, 5, 13, and 23. Okay? So, yesterday, I said that these values were y values. Okay? That is our output. Now, it says starting with n equals 1, what is the function rule? So, it tells you what to start with. So, I want you to make a chart, and I want you to write y. Well, in this case, they're not using x, but they're using n. So, when you put in a positive 1, you should get out a negative 1. When you put in a 2, you should get out a 5. When you put in a 3, you should get out a 13. And when you put in a 4, you should get out a 23. And it just keeps going, okay? So, now we have 4 choices, okay? And he wants to know what is the function rule. So, when I plug in a 1 for each of these functions, according to my chart, I need to get out a negative 1. So, for the first one, I'm plugging in a positive 1. So 1 minus 2. Well, that one works. But just because that first one works, does that mean that the next one works? No. So now we should plug in a 2. And we're supposed to get out the number 5, but we get out 0. So we know that A is not our answer. Okay? So let's move to B. First, we are plugging in the number 1. That's not right. Hold on. Plugging in 1 plus 10. Well, according to my chart, I'm supposed to get out a -1. But I got out the number 11. So B is not correct. So let's move to C. So first, I'm plugging in the number 1. And I'm using parentheses anytime I plug in a number. So when I plugged in a 1, I got out a -1. So that one works. Okay? So now let's move to plugging in the number 2. When we plug in the number 2, oops. We get out the number 5. So that one works. So now, here we go. I want to try the number 3. Three works. And so lastly, we should try 4 to make sure 4 works. $23. So when I plugged in a 1 for C, I got a -1. When I plugged in a 2 for C, I got 5. When I plugged in 3 for C, I got 13. And when I plugged in a 4 for the letter C, I got 23. So C has to be our answer because it satisfies the conditions of plugging in each number for the letter N and getting out these Y values. Okay? All right, so now I'm going to move to number 4. Number 4 is a chart, and it starts with, for the first week, I'm running 3 miles. Second week, I run 6. Third week, I run 9. Fourth week, I run 12. And the fifth week, I run 15. So it says, what is F of 1? Well, you have to go to your chart, and you have to find where it says F of 1. So when I see F of 1, I'm getting out the number 3. The second part says create a recursive function that defines the number of miles Joe will run during the nth week, where 2 is less than or equal to n less than or equal to 5. So, what that means is recursive function, and it asks for the nth week. So you know that you're going to have to use n minus 1. Okay? Now, we have to determine first what kind of sequence this is. So from 3 to 6, we can do 2 things. We can multiply by 2, or we can add 3. From 6 to 9, we have to add 3, so we know we cannot do this multiplying by 2 every time. So from every mile, we are adding 3 miles each week. So, first, common difference. Every time we're doing what operation? We are adding. Then we are using the recursive definition, because I have to know the term before to get the term I'm currently doing. So I'm going to write it down here at the bottom. F of n equals 3 plus f n minus 1. Okay? All right, number 5 is kind of like number 3. Consider the table. So my x values are 1, 2, 3, and 4. And my y values are 4, 16, 64, and 256. Select the correct function rule. So this time, I'm going to show you how to use your table. So in your y equals, you can go up here and you can type any of these functions, A, B, C, or D. So let's start with D. 4x. And I want to hit second and graph to pull up my table. So according to my chart, when I plug in a 1 for x, I need to get out of 4. Well, it looks like that one works. According to my chart, when I plug in a 2, I'm supposed to get out of 16. But do I get out of 16? No. So D is not my answer. Now, let's try A. 4 to the x power. That is an exponential function. When I plug in a 1, I should get out a 4. Oops, sorry. Oh well. When I plug in a 2, I should get out a 16. When I plug in a 3, I should get out a 64. When I plug in a 4, I should get out 256. Okay, so which one has to be my correct answer here? A. Okay. All right, now on number 6, it says, the first term of an arithmetic sequence is 12, and the fourth term is 27. Which of the following, but it shouldn't say which of the following, because you don't have answer choices. What is the general term of the sequence? So we have to write the equation, basically. Okay, so A1 equals 12. That means the first term. The fourth term is 27. So what this means is when I plug in a 1, I get out a 12. When I plug in a 4, I get out a 27. So then you have to do y2 minus y1 over x2 minus x1. This is an x, this is a y, this is an x, and this is a y. 27 minus 12 over 4 minus 1. 15 over 3, which simplifies to, it's kind of hard to see, simplifies to 5. Okay, so now we know that our common difference is the number 5. Okay, so same thing as always. It goes the first term, then it goes my common difference, and we use that recursive definition again. So we know the first term is 12. We know our common difference is 5 because that's what we just solved. And the recursive definition is n minus 1. So it looks like an equals 12 plus 5 times n minus 1. Okay? All right. This is the last one on topic 1 questions. So let me go to a new page. All right. So up top, Okay, guys, I'm going to have to pause my video and charge my pen up because my pen will not let me write. So I'll be back. I'll go ahead and upload this, and I'll be back in just a little bit.